Hi everyone! In my last video, we saw how security operations work with Microsoft Security MCP servers. Specifically, we were using the data exploration tools that queries the Sentinel data lake for different tables in order to conduct investigations. Other than the data exploration tools, Microsoft Security MCP servers also provide triage tools that help with agentic investigation and threat hunting. So the data exploration tool looks at Sentinel data lake. The triage tool looks at Defender and the Sentinel SIEM workspace itself. This provides flexibility because it uses the Defender RBAC roles for Defender-related queries, which is very much similar to the Microsoft Graph Security API. And for Sentinel workspace queries, it just leverages on the Azure IAM roles. There is a limitation where the tool itself doesn't allow specifying of workspace selection, but cross workspace query still works just as with the workspace command using any log analytics workspace log query. And then to make this work, it integrates with Visual Studio Code, which is the currently only supported agent platform. It serves as the IDE and MCP host that is the main interface for the security operator. And of course, GitHub Copilot is the LLM engine that reasons on the prompt, use the MCP servers to generate response based on the context. So let's take a look at how it works. Over here, I actually have my account logged in as the administrator, where I configured device group for alpha servers. So we are actually looking at the group of alpha servers in this video's context. And for the Defender RBAC itself, I have configured alpha admins, which I have grant very minimal permissions for security data read access, which is the bare minimum required for Triage. And in terms of the assignment, pretty much the operations that we are going to see today in this video is just the Defender for endpoint, not so much from Defender for cloud. And from the perspective of the alpha admin, it has access to the Alpha SOC Sentinel SIEM workspace. This is the one that we will be running advanced hunting queries on. And in terms of the device, indeed, it is scoped to all the alpha servers. So let's jump into the VS Code to look at how we configure the triage tools. So for VS Code itself, it works with GitHub Copilot. So what I have over here is actually GitHub Copilot that is signed in with a GitHub Enterprise account. Adding the MCP server for triage tools is actually quite straightforward. Just from a command bar, go to show and run commands and add MCP server. Then the MCP server for triage tools is a HTTP streamable remote server, which means that it's a hosted server by Microsoft. So there's no need to run any UV or npx commands. So we support select HTTP, and the URL is on the documentation itself over here. Oh, this is a good point to note that the triage collection right now is under preview. And the URL is given right here. So let's go copy it and we'll paste it here. Give it a name. So the name is useful because I mentioned just now that you can't really scope the workspace. So there might be situations where you will need to log into different MCP tools with different accounts. So the moment that it's connected, it tries to authenticate. I'm going to allow this. So in my account, I have already connected quite a few accounts, of course, including the admin accounts that we saw. We'll be using alpha accounts. So if, let's say, there is no accounts currently logged in, just select login to another account and we will bring you to the very familiar Entra login. So since I'm already logged into alpha, I'm just going to select alpha. You can see that the MCP server is actually running with 27 tools. So this is also a good point to note in terms of configuring tool. Let me just bring out the chat to a bigger window so we can focus on this. So we can select the tools that is given here. One point to note when using things like Agentic SOC is that the more tools you grant to an agent, for those that are very familiar with AI agent workflows, we already know this. If you enable like all 27 tools, every single prompt that you run on the agent is going to fit all 27 tools into a context window. So this would firstly take up precious context window space. And secondly, because most of the tools over here is going to have very semantically similar purpose. So if you were to just add all the tools to the agent itself, sometimes when you give a prompt, it might not be able to take the right decision. So I have scope for this video's demo, scope to things like listing and getting alerts, incidents, and we will be doing a bit of file analysis and hunting in this. And of course, we would need the run advanced hunting query because we will also be looking at using the agent to query Sentinel SIEM workspace. Let's try to get some incidents in the past 3 days. So very quickly, it identified that this incident is a convenient tool to use to find out all the incidents, and it only takes one input, that is the time scope that is required for filtering. So back to the tool selection, of course, when we enable just a limited amount of tools, it's easier for the agent to find the right tools. And then within the environment itself, it's going to find that I have 10 incidents, and the one that I have prepared for this video is this high severity incident. So let's look at some of the alerts that are seen on this incident. So again, instead of going into the incident, clicking, and then finding out everything, I can just ask get alerts. The agent quickly identify that the tool to use is get incident by ID. So from the incident details page, is able to find that there are a total of 3 alerts. And from the timeline of it, is going to see that it probably started from get initial access, and then after that it tried to do a lateral movement. This sounds like something like it's trying to drop a payload to get a remote connection back. So you can also see that it's specified here whether the alert actually came from Sentinel or came from Defender XDR. So a very quick overview of the incident, exactly what is happening. So since we see some alerts that is coming in from Sentinel, let's maybe find out what we can on if there's any login failures and find out exactly what happened. Of course, the alerts, while this is working, let's scroll back up. Of course, the alerts itself already give a very high level summary on the targeted users, the source IP, which actually looks like public IP addresses. And we're just going to test and see how the login failure is like. And the good thing is that we can actually even preview the query. So sometimes it's convenient to get the agent to generate the query for you and just run the two query. So it's concurrently going to run both for security events, which is the Windows events, and the syslog events for the Linux VM. So this creates a very simple interface where you just need to prompt and it will table up very nicely onto a format that it just come back as a response. So it's just all in one pane. So maybe let's dive down a bit more on the machines. So let's quickly see reviewing the machine information. And I'll just click allow while looking at the agent's reasoning. So it's actually able to see that from the previous alert, it saw the 2 device ID and it just straight away used the device ID for the get defender machine tools. So maybe at this point, we got the information on the events from Sentinel, we got information on the machines. Let's move it up a bit to look at more on the malware that is detected on these 2 machines. I'm being a bit more precise over here because I want it to look specifically into the defender tables for alert info and device events. So then it will try to query these 2 to find out if there are any alerts that are associated with these 2 machines. So once in a while you would see let me just allow this first. Once in a while you would see that the agent did not manage to run a particular query. This is quite normal. Ultimately is using a LLM to generate KQL query. So sometimes it does make semantic errors. And we saw that one more of it has failed again. Probably didn't manage to find out the schema of it. So a convenient thing here is that if you see if you try to run hunting query as we saw as a human operator, right? We try to run like alert info, we probably need to find out what's the schema. We need to run the initial query just to get all the columns and then find out what columns to keep, etc. So within seconds, the agent actually corrected the query itself and presented all the details over here. Maybe let's see if we can dive down to see if there are more details on the files. So I'm running this prompt just as a rather more vague approach to see whether it can figure out what tools to use from the Triage tool collection. So it is actually reasoning and it's going back to the alert ID. Not quite what I have intended actually. So I'm actually hoping for it to use the get defender file tools. Oh, actually, see, so sometimes the agent does take a few iterations to figure out the right tools. So it actually try to run gets alerts by ID, and it found the file hash information from the malware. So it's actually pretty smart. It knows that it needs the file hash information. And it runs the respective get defender file info, statistics, related machines, and the alerts. Let's go ahead and run everything. And look like it hit some error again. So sometimes there are indeed cases where the inputs of similar looking MCP tools may actually require different format. So for the other tool, we actually use the SHA-256 format. It works well. But for this particular tool, it requires SHA-1. So again, the agent corrects itself, and I believe, yes, it's trying to send it again with the SHA-1. So this addresses very common questions like if a malware is detected, what is the extent, what is the scope, where was it first seen, what does it do, and it just runs different tools together and generate output for the operators to see. So again, it resonates that with agentic security, we don't really need to figure out on how exactly to get the information, or rather we focus on what can we do with this information. So that brings our very short demonstration to a close. Based on what we have seen earlier, right, there are two main points to note when we are trying to use agents to work with security. So agentic security is actually not magic. It is LLM using tools to retrieve additional context so that it can provide results. That is where, of course, prompt engineering is still critical. Try to be as precise as possible, because we, as a general notion, garbage in means garbage out. If we ask precise questions, it guides the agent in the right direction and have better results. And the agent uses LLM, which is non-deterministic in nature. So the same prompt sequences can result in different outputs. But the whole idea is that the data is right there and the agent has the tools to retrieve it. And lastly, in the demo that we saw, we managed to get quite good quality output, but sometimes mistakes can happen. Sometimes what we see is that the agent not finding anything doesn't mean that it didn't happen. So it is still back to the human operator to ensure that it has already expanded all the searches that it can do. So the agent is here to help to get the information. The operator is there to guide, to make sure that investigation is going the right direction. Which brings to the second point. Iterative improvement is important. So we can always start investigation broadly. This is the same as normal incident response flow, right? Where you receive an incident, you look at it at a broad level, and then based on the alerts that it's seen, the file, the IP address, and zero in to the target on exactly what verdict to push. Analyze the agent reasoning to validate that the investigation is going in the right direction. So we saw in the demonstration that the agent managed to figure out what we are trying to do. but sometimes if you give it some one-shot prompting and just try to let the agent figure out itself, it can go very far off. And then we also saw that within VS Code itself, the chat window, we can see the reasoning, the input, and the output. So this is where it's also very helpful, where we can analyze the tool usage. The KQLs that were generated, right, can actually be copied and pasted into the Defender portal to run manually. So that brings me to the end of this video. I actually have it documented within my GitHub, which I will share in the link below. It actually consists of the high-level overview of how we can use what are the preparations that is needed, what are the permissions with different tool collections. And I will keep this document live as this tool is still in preview. It is just been released recently. So as there are any changes, I will update in the GitHub write-up. And I will see you in the next video.